Well, how are you feeling? Good? Are you game for maths? Maths with Kumar will not be so stressful, let me tell you that. Alright, today we're learning something new on trigonometry. But have no fear. Alright, I'll take you through Trigo from scratch so that you will see and get to understand it in the easiest and best way. And you will get to know that the importance of this chapter as we go along, because what we'll start is what is trigo, what's the use of it, how do you use sine, cosine, tangent, and how do you use these formulas in solving problems. And after which the next level will be the application of trigonometry in finding length, sides, angles, areas. And that's where you're going to get to sine rule and cosine rule. You heard of it, haven't you? But don't panic. Once you get to know about it, as you develop from stage 1 to 2 to 3, and you get to bearings, all right? With all this fundamental knowledge, you will be up there, all right? But just before we get to trigo, I'd like to revise with you a general revision on Pythagoras theorem. What is Pythagoras theorem? And if you look at this, you look at a triangle here, triangle, and you have A, B, C. You call the longest side the hypotenuse. Please don't call it hippopotamus. All right? You call it again? Hypotenuse. Yes. Now this is the hypotenuse. And the hypotenuse, how do you recognize it? It's the side that faces the 90 degrees. That's facing the 90 degree. These are just adjacent sides to 90 degrees. Alright? Now, the hypotenuse facing the 90 degrees is the longest side of the triangle and is made of c squared is none other than a squared plus b squared. This is Pythagoras theorem. And amazing, you just draw it out in your paper. Just draw any right angle, measure the side here, measure this side, square them, like what you did here, and see if it is the sum of this, if it's the square of this length. Alright, you will discover that. And no matter whatever size your right angle is, no matter how small, big, whatever, you can draw a triangle that is very thin this way. You can draw a triangle that's very big this way. All right. Let me draw another one. A triangle that has got huge length here and very short length here. All right. Whatever it is, the square of these two distances will be equal to the hypotenuse. All right. The hypotenuse is here. And I think they rightfully called it right hypotenuse because it looks like the hippopotamus of the triangle. All right, hypotenuse, hippopotamus. God knows, maybe Pythagoras, this gentleman, find out more about him. He could have linked it that way. How did he get this name? Perhaps you can do a finding on that and share it with me if you can, Kumar. All right, let's look at this. You need to find out what is this length, if you remembered. 3 squared plus 4 squared equal to x squared. So x squared is going to be 3 squared plus 4 squared. 9 plus 16, you get a 25. And hence, your x will be the square root of 25. That is a 5. Okay? Now, if you look at this triangle, you have 20 meters. Here is 12 meters. What's the length here? Give it a name. Call it maybe A. These are sides. You got to recognize where your hypotenuse is. Ooh, that's there. So 20 squared is none other than A squared plus 12 squared. And you got 20 squared, 20 times 20, pretty easy. 2 times 2, 4. And you get 2 zeros there from here. So it's 400. And if you look at 12 squared, 144, you minus your 144. What do you get your a squared to be? All right, look at it. 400 minus 100, you have 300. And then from there you get a minus of 44. You get 256. So your a squared will be equal to 256. And the square root of it will be 16. I know when you find square root, you've got a plus 16 and a minus 16. Can the length be a minus 16? Where does that go? Minus 16. Can a length ever exist? Where is the minus 16? That's when you totally say reject. So A is 16. Alright, now let's look at another few more examples before we move on to trigonometry. Alright, now we look at 3, 5, and this is H. What is H going to be? Well, this is going to be the hypotenuse facing the 90 degree. Right? 3 squared plus H squared is 5 squared. And that means your H squared will be 25 take away 9. And that's equal to 16. So your H is going to be 4. And if this length is 4, alright, what is Y going to be? Now these are adjacent angles on a straight line. If you have 90 degrees here, this will also be 90. Now remember, the very condition for Pythagoras theorem, it must be a right angle triangle, not in any other triangles, alright? So that's why we created a right angle triangle here. And you have H, you have 7, and you want to find out what is Y, alright? Now, and it's also, if you can do that, you can find out what is Y. Your Y squared is going to be H squared plus 7 squared. And so your Y squared is going to be, look at that, H squared plus Y squared is H squared plus 7 squared. That's the hypotenuse facing the 90 degree. Right, so look at it. Your H is a 4 squared, 7 squared, a 16 plus 49. When you add that up, what do you get your Y to be? Please help me there. 50, 56, 65. Right, that's Y squared. And Y will be the square root of 65. Have I made a careless mistake? No. Right, okay. So you've got Y, the square root of it. Now we wonder, I want to ask you, can this angle ever be 90 degrees? If you want to find out, is it so? If it's so, then if your Y is a square root 65, this should match. If this squared, Y squared plus 5 squared, if your Y squared plus 5 squared is equal to this whole length, 3 plus 7 is 10, 10 squared. If, let's find out, that's 65 square root. When you square root 65, you square it, it becomes 65. And this is 25. You want to find out. And this, you get 80, you get a 90, and a 90 is not equal to 100. Hence, this angle here is not 90 degrees. Alright? So you want to test it. If it's 90 degrees, it must be following Mr. Pythagoras, his theorem. Alright? Pythagoras theorem. Got it? Right. We can move on a little bit, and then I'm going to get to trigonometry. Now you look at this again. You've got an 8, you've got a 17. You want to find out your x. You want to find out your y. Are you comfortable with this? I always tell my students, those who come to me, I said, hey, don't be a nerd, you know. Don't rely on the calculator too much. Know your tables, know your squares from 1 squared to 25 squared. 1 squared to 25 squared. Like what is 13 squared? 169. What's 14 squared? I look at the amazing figure of numbers, 13 squared. That's that. 14 squared. Reverse the numbers, 69 becomes 96. Hey, that's 14 squared. And you've got to see patterns. Like if you look at 17 squared. Now you look at 7, it ends with a 9. 17. squared, it is 289. It's not very difficult. If you look at 18 squared, it ends 8 times 8, 64. And these two numbers, you just got to remember it's more than 200, less than 400. Well, it's 300. And this center number is what you got to remember. And 19 squared, 9 times 9 is 81. It can't be 4 for the hundreds. It's 3, and this is 361. 20 squared, I'm sure you know. And 21, similarly, if you look at 21 squared, you know it's 1. It's slightly more than 400. You get 441. All right, move on with Grace. You can see a 22 squared is 484. 23 squared, if you can help me there. Is it 576? I think so. Wait. Nope. 3 times 3 is a 9. I think it's 529. Alright? And if you look at 24 squared, it's a 576. And a 25 squared, it ends. You look at it, 24 squared again. 4 times 4 is a 16. 25 squared is 625. It's good to have all these in your head. And just like the cubes from 1 cube to 12 cube, it will be really good, especially when you have to find so much of square roots and all these. You have an approximate picture. Alright, this length is about 8 point something. Square root of 65 is about 8 point something. Now you look at this. You want to find out what is x. Alright, what do? We said x squared plus 8 squared is equal to 17 squared. And you know what is 17? 2, 8, 9. And this is 64. So you got to bring that over. Your x squared will be 289 minus your 64. And that will give you a 5, a 2, a 225. Alright? That's an interesting figure. X squared is 225. And what is 225? The square root of it? 15. I remembered. I must share this joke with you. Don't laugh too much and keep it silently to yourself. I was teaching at one of the schools some years ago, a good 20 years ago, and I was quite scared of this huge, strong guy who sat in front of me. I asked him what is 5 cubed. He looked at me and he shouted, 1 to 5. I said, what? 1 to 5? He wanted a fight with me? All I asked him was 5 cubed. 1 to 5? I said, what again? 1 to 5? I heard it that way. But actually he was saying 1 to 5. I got that. I was a little worried for once. Alright, not now anymore. I've become a much more mature teacher. I can take him on. Alright, 5 cubed. 1 to 5. 1 to 5. Remember the fight, to fight. 5 squared. So I got this as a little hamper, to 5, to fight. And I said 15 squared. 1 to fight, 2 to fight. Oh, this is dual fight. 2 to fight. And I said 25 squared. Oh, it's a gang fight. What do you guess it to be? Alright, 6 to 5. 6 to 5. That's how you connect numbers with your own version. And I thank this lovely boy, actually, for teaching me how to be a better teacher. Alright, and I know some rough youngsters, they feel so great to fight. Alright, I hope you're not one of them. So you say to fight. 15 squared, 2 to 5. 25 squared, 6 to 5. Oh, gang fight, run away. Alright, let's move on. This is just a package that you can remember and keep that secret learning numbers. Just like here I told you 69, 169, here is 196. In Singapore, what we do is we have a bus that goes down 169 that goes to Yishun, Sembawang area. And I remembered I'm supposed to go down to Jurong, when I was a young girl. And I took this bus, 196. I got confused. because these two buses came at the same store. Oops, 196, and I ended up somewhere. And then I realized, oh my God, it's supposed to be 169, wrong bus. All right? So sometimes little stories, little anecdotes in your experiences can help you to make connection with numbers. All right? I'm sure you can connect with birth dates and whatever. All right. Okay, so let's look at this. Now you want to find out what is x. You've got x squared. This squared plus this equals to 17 squared. Your x is square root of 225. What is that? 15. Great. So your x is 15. So you said, hey, you're 15. And now what must y be? Because this big triangle is a right angle triangle. And that's your hypotenuse. Now we'll look at it. Now I'm looking at this big triangle. It's your hypotenuse. So this whole length, I keep it as a big X. Big X plus 8 squared, all right, is equal to 24 squared. And 24 squared, you could get in your calculator for the moment, but I truly advise you to know your tables. 24 is near 25. It is near the big gang fight. It's 576. And this x squared plus 64, bring the 64 over, you get a minus 64. Hey, 6 stick with 4, 2, 1, 5, 1, 2. That's your x squared. And sorry, your x will be the square root of 5, 1, 2. Now these are numbers that sometimes you need to help to get the calculator to help you find the square root of 5, 1, 2. Look at the square root sign. Where are you, square root? I've got to get that square root sign. Look at the shift button. Yep, I got it. Now get your square root, put down 5, 1, 2 and press equal. You get 22.6263. So let's round out. X is 22.6, and hence as x is made of small x plus y, x is made up of small x plus y. Well, this is 22.6 and that's 15. So what is y made of? 22.6 minus 15. You get a 7.6. So you see, the use of Pythagoras is very easy, finding out length. And its real measurement is the truth of numbers. Alright, this amazing man, Pythagoras. I sometimes like to find out more about him. I like his name, close to the name of Pythagoras. His amazing strength, the amazing discovery that helped us discover more things in mathematics that we moved on now. Because of these things, we can go into further measurements, all right? Now let's look at trigonometry. Now trigonometry, in this case at the level 1, we apply the first level if it's a right angle triangle, right? If you look at the right angle triangle, if you have an angle here x, and this is A, B, C. Now we look at tangent, all right? Tangent, the short form is tan, short form. Cosine, the short form is cos. And sine, the short form is sine, sin, like that, sin. All right? Now, if we look at tangent, all right, tangent x. Now, I would like to say tangent is the opposite over the adjacent. Opposite over the adjacent side. Who is opposite? Well, this length is always going to be the hypotenuse. It's not going to change, that's going to be the hypotenuse. So tangent x is b over a. All right, the opposite side. Please don't get it wrong. Opposite, x. Who are you? B over A. The next one, if you look at sine x, sine is it's actually opposite over the hypotenuse. All right, and who is the opposite? The opposite side is B over C. That's your sine, the rule. Sine is opposite over the hypotenuse. And for cosine, cosine x is adjacent. Adjacent, what does it mean? Beside you, adjacent to you. When you say opposite, it's across you. I'm opposite of you. Right across, I'm sitting across. Adjacent to you, maybe your mom, maybe your dad, or maybe your friend, your best friend, or your girlfriend, or your boyfriend, whatever friend. Adjacent, next to, it can be the right, it can be on the left. So adjacent to cos, the adjacent will be an A. Let me write here first, adjacent over the hypotenuse, and the adjacent is A over C. Now I'd like you to be familiar with these names, the formulas, all right? And we will then go into more sums to understand trigonometry. I hope you've got your Pythagoras in you. A squared plus B squared is equal to C squared. And the biggest side of the triangle is called the hypotenuse. Is it? Hypotenuse, yes, not what it's supposed to be. Have fun, and we'll have more sums.